Today we're going to continue with section 12.2. Today we're going to look at multiple comparisons, and you can use a date of May 14th. Yesterday when we ended our notes, we had run a couple contrasts. Remember, contrast would be set up prior to running the experiment, and it's usually because you're already hypothesizing some kind of relationship between the means. However, in many studies, these are not questions that you can prepare in advance because you're just not sure. So, if you reject the null hypothesis and you have evidence that the means are not all the same, it's still helpful to know which means are different. So if you're unable to prepare a contrast prior to setting up your experiment, what you can do instead is run a multiple comparison. What this will do is it will pair different means together, and we'll look at their differences and then try to determine if their differences are significant. These are often called pairwise tests of significance. Remember, when you run an ANOVA, we're assuming that all the means are the same. And if that's the case, we're saying that all of our different groups come from the same population. So even if we're running pairwise tests, we're going to use the pooled estimator, so the standard deviation that's pooled, and this will increase the power of the tests. When you set up your hypothesis testing for your pairwise tests of significance, we do want to use a two-sided alternative. So when you perform your multiple comparisons, we're going to run a bunch of t statistics for all the pairs that we're interested in. This formula should seem familiar. So this will be our t statistic using our two different means or groups. So we're going to subtract the two means. We're going to use the pooled standard deviation. And then under the square root radical, we take into account the size of the sample for both groups 1 and 2, or whichever groups you happen to be comparing. If you can show that you have a t statistic with a significant p-value, we can say that the means are different. Because you might be running 5, 10, 20 different t-tests, one of the methods is called the least significant difference, and it's one way that you can choose your critical value for your distribution. And remember, alpha over 2 just implies that we're running a two-sided test. What we'll do is we'll run out all of our various t-tests, and we'll select all those comparisons that fall below our level of significance. Typically, alpha is set at 0.05. If the value of your sample size is too large, this method is going to be very tedious, and they're saying that it has undesirable properties. That's because you'll be running t-tests until the cows come home. Instead of running all those different pairwise t-tests, what we can do is set a level of significance and then use the Bonferroni method to help us select the means that are actually significant. So instead of coming up with 15 pairs that seem significant, Bonferroni will help us narrow it down, and it will change our alpha value. So typically with Bonferroni, we'll take alpha and we'll divide it by k, the number of tests that we have run, and that will drop the significance level, and then we'll select all the t-tests that fall under that new modified alpha. We can also set up simultaneous confidence intervals for all of our differences so that we can see if any contain 0. The confidence intervals are all set up like we've done them in the past. You would find the difference between the two means that you're comparing. We would use the required critical value for t, and then we would use our pooled standard deviation. And then again, we're factoring in the sample size for each of the two being compared. If you find that 0 falls in your confidence interval, then we know that that pair of means is not going to be significant. We could go on to run t-tests to prove it, but usually the confidence interval and the t-test go hand in hand and they confirm each other's results. So what this tells us is that a contrast is going to be a more powerful comparison tool than running a multiple comparison test. They're better at picking up any kind of significant difference between means. That's all the notes that we're going to cover today. There's no homework assigned with this lesson, but if you do have any questions, please make sure you contact me. Have a great day.